Periodic waves. The transverse and longitudinal waves that we have been discussing are called periodic waves because they consist of cycles or patterns that are produced over and over again by the source. As discussed in simple harmonic motion and introduced the concept of cycles, amplitude, period, and frequency, the same terminology is used to denote periodic waves, such as the sound waves we hear and the light waves we see. So here, the figure are the graphical representation of a transverse wave. One cycle of a wave is shaded. A wave is a series of many cycles. So in figure above, it shows the vertical position of a point corresponds to the distance along along the length. While in the figure below, it illustrates the vertical position of a point in the instant of time or in respect to the instant of time. So there's a difference between the wavelength and period. So when we say wavelength, it refers to the length or distance of one cycle, while period is the length of time for one cycle. The amplitude is the maximum recursion of a particle of the medium from the particle disturbance. The maximum point or the maximum height is what we call crest, while the minimum point is called throw. Simply to get the amplitude, you just get the point or the midpoint between the crest and throw and getting the length from the midpoint to its either maximum or minimum point, then you can get the amplitude. Or we just simply get the maximum point minus the minimum point divided by 2. Let's say we have the amplitude here or the maximum point here at 5 and the minimum point is negative 5. To get the amplitude, we can simply get 5, which is the maximum point or the point of the crest, minus negative 5, which is the negative 5 is a point of throw, divided by 2. Then we can get the amplitude of 5. The wavelength, which is a symbol of lambda in Greek letter, is the horizontal length of one cycle of the wave, while the period, which is symbol of t, is the time required for one complete cycle. The frequency is related to the period and has a unit of hertz, or s raised to negative 1. And we know from the simple harmonic motion that that frequency rather is equal to the reciprocal of period. And to get the speed of a motion or a wave, we just simply get the wavelength or the distance traveled divided by the time it takes for that one cycle. Or simply, the velocity of a wave is equal to frequency times the wavelength. The electromagnetic waves or radiation refers to the waves of the electromagnetic field propagating through space, or it does not necessarily need a medium to travel. It can travel through the vacuum or through space. It carrying electromagnetic radiant energy. It includes radio waves, microwaves, infrared, light, ultraviolet, X-rays, and gamma rays. All of these waves form part of the electromagnetic spectrum, including also the visible light. So electromagnetic waves are not mechanical waves, but they have this motion that's related to the mechanical wave, which is in sinusoidal motion. And later on, we will discuss about sinusoidal waves. For our example problem, AM and FM radio waves are transverse waves consisting of electric and magnetic disturbance traveling at a speed of 3 times 10 raised to 8 meter per second. A station broadcasts an AM radio wave whose frequency is 1230 kilohertz and an FM radio wave whose frequency is 91.9 megahertz. Find the distance between adjacent crests in each wave. So we are looking for the wavelength of AM and FM. And to get the wavelength, we can use the formula of velocity divided by frequency. Since we have the given value of velocity, which is 3 times 10 raised to 8 meter per second. To solve for the wavelength for AM radio waves, we use the formula of lambda or wavelength is equal to velocity over frequency, wherein the velocity is equal to 3 times 10 raised to 8 meter per second and frequency of 1230 kilo, which is means times 10 raised to 3 hertz, where hertz is equal also with let's replace hertz with the unit of s raised to negative 1, so we can obviously cancel the unit for time. Therefore, the wavelength for AM wave is equal to 244 meter. Now, for the FM wave, using the same formula of wavelength and same velocity of 3 times 10 raised to 8 meter per second, and the frequency for FM is 91.9 mega, which is equal to times 10 raised to 6. Cancel the unit for time. Therefore, our wavelength for FM is equal to 3.26 meter. So this is the distance between the two adjacent crests. So remember, the crest is this maximum point, and this minimum point is the trough. Now, try to solve this problem.